Hello everyone. Aren't you impressed that I didn't start with the word right? Apparently that is what I do. So we have changed technique. Right, welcome to another episode of Matric Corona Maths. And we're going to look at second and higher order derivatives. And we'll start with a monster example. We've got f of x is equal to 4x to the 5 minus 2x to the 4 plus x cubed minus 5x squared plus 7x plus 1. So, everyone go find the first derivative of that. Okay, so f dash x is going to be equal to 20x to the 4 minus 8x cubed plus 3x squared minus 10x plus 7. So that's what we call the first derivative of f of x. If we now go say go find the second derivative, well, the notation we use, we can either write f double dashed of x, okay, or we can write f in brackets a 2. That means the second derivative of f of x. And all the second derivative of f of x means is that you differentiate the original function twice. So in other words, differentiate it once here to get the second derivative. I'm going to differentiate it again, then I would differentiate it twice in total. So the second derivative is going to be of f of x is going to be 80x cubed minus 24x squared plus 6x minus 10. 80x cubed minus 24x squared plus 6x minus 10, derivative of constant falls away. Right. Then if I said to you, go differentiate 3 times, the third derivative we could write like that, or we could write it as f with a bracket 3 of x, okay? And that means from the original we differentiate 3 times. So I differentiate it once, differentiate it twice, now I differentiate for a third time, and it's going to be 240. So it's nothing new really, guys. 240x squared minus 48x plus 6. Just one thing that's been worrying me, Sarah Jacobson, I hope you're not still eating raw lasagna. We have been concerned. If you need a food package delivered, we'll make a plan. Okay, f3 of x, so f3 of x is going to be that. Okay, the fourth derivative, which starts to become a bit ridiculous writing them like that. I would definitely write a fourth derivative if you were ever asked to find it, which I doubt you would be. The fourth derivative, though, just out of interest, would be 240 times 2, I think is 480 x minus 48. So there's your fourth derivative. And your fifth derivative, which I'm just going to write as f5 x, your fifth derivative is going to be 480. And then what we can say, okay, is that f for some general value n of x for the nth derivative, so anything after this, the derivative will be 0. So f n of x will be equal to 0 if n is a natural number and n is greater than or equal to 6. Because the sixth derivative would be 0, the seventh derivative would be 0, the eighth derivative would be 0, etc. So that's simply what higher order derivatives are. It just means keep differentiating. Fifth derivative means differentiate the original one 5 times. Generally, we only work up to the second derivative, especially when you do applications. The first derivative's got to do with gradient. If you sub into the first derivative, you get the gradient. And for the second derivative, we use as well, because you'll see later on, if we sub into the second derivative function, okay, what we're going to get is the concavity of the graph, which we'll describe later. Okay. Right, in the second example, I just want to show you some different notations. So if you've got y is equal to 4x cubed minus 7x squared plus 2x minus 11, and I want to go find higher order derivatives, well, the first derivative we'd write as dy dx. The second derivative we'd write as d squared y dx squared. The third derivative like that, d cubed y dx cubed. And the nth derivative, dn dxn. Right, but the process is the same as the previous example. The second derivative means go differentiate the original one twice. It's just different notation, differentiate 3 times, etc. Right, so give that a go. See if you can do that yourself. Righty then, so the derivative is going to be 12x squared, the first derivative, minus 14x plus 2. There's your first derivative. If I differentiate again, it's going to be 24x minus 14. Okay. Oh, listen. The dishwasher's finished. Okay. The third derivative, where's my wife? She should be running here. Falling aside. The third derivative is going to be 24. Okay. And if I differentiate again, the differentiate of a constant function is 0. So the nth derivative is going to be 0 for all n greater than or equal to 4. N is an element of natural numbers. Lovely, lovely stuff. Right, as a modern Renaissance, I said right. As a modern Renaissance man, I was obviously joking about my wife having to go, my darling, lovely wife, having to go clear the dishwasher up. Of course, I will be doing that duty, okay, because we are equals here
BS.
in this household. Right, so just some other notation. Remember, this is an instruction. This means go differentiate negative 7x to the 6 plus 3x to the 4 minus 2x 3 times. Okay, differentiate that 3 times. So, I'm going to differentiate it. That means I've got to still differentiate it 2 more times. So I've still got to go find the second derivative of this derivative over here. And that derivative is going to be minus 42x to the 5 plus 12x cubed minus 2. So I've differentiated once, I've still got 2 more to go. Okay, so I differentiate that, which means I've only got 1 more to go. If I differentiate that, I get 5 times 40 is 200, so it's going to be minus 210 x to the 4 plus 36 x squared. I'm trying really hard with my handwriting today.
Good.
I think it's looking good. I think it's looking good.
Looking
Right.
better.
So if I differentiate that, tough crowd here, I get minus 400. Is that right? 210. If I made any deliberate errors, please let me know. Nearly. 4 times 200 is negative 800. Okay, and 40 x cubed plus 72 x. And now, okay, I've differentiated once, twice, and 3 times. So that, the third derivative of this whole thing, there's your final answer, is going to be equal to negative 840x cubed plus 72x. Exciting stuff, exciting stuff. Okay, you got it? I won't say right, I'll say greetings and salutations. So, all that is left to do for today's lesson is exercise 8.8 from your classroom maths notes, which is on page 208. And then for your test next week, I think it's on the 7th, your last test. And remember, there's always one that you can leave out of your term mark. A good revision exercise is the check your skills from classroom maths, exercise 8.9, page 209, and I will send you a full worked memo. And that, ladies and germs, is that. And we will see you soon to do some. Can we have a drum roll, please? Trigonometry!